Ever wondered, what could possibly wipe out entire civilizations in the cosmos? Imagine the cosmos for a moment. It's an expanse so vast that even our greatest minds struggle to fully comprehend its scale. It's an infinite canvas, dotted with countless stars, each potentially hosting its own unique civilization. Some of these civilizations could be just beginning their journey, while others might have already spanned across galaxies. Yet, despite the breathtaking beauty and infinite possibilities, space isn't just an endless playground, it's also an arena of cataclysmic forces and cosmic phenomena that can spell doom for even the most advanced civilizations. Picture this: there are black holes, regions of space where gravity is so strong that nothing, not even light, can escape their grasp. They can rip apart stars and swallow entire planetary systems, leaving no trace behind. Then, there are supernovae, the spectacular death throes of giant stars. They unleash such immense energy that they can outshine entire galaxies. The resulting shockwaves can obliterate nearby planets and sterilize others with lethal doses of radiation. We also have gamma-ray bursts, the most powerful explosions known in the universe. Originating from collapsing stars or the merger of neutron stars, these bursts emit intense beams of gamma rays that can eradicate life on planets thousands of light years away. And let's not forget about cosmic radiation. It's a constant shower of high-energy particles that can damage DNA and increase the risk of genetic mutations, potentially causing a slow death for civilizations unable to shield themselves. These are just a glimpse of the many cosmic phenomena that exist in our universe. They are a testament to the fact that space, while a cradle of life, can also be a harbinger of destruction. It's a paradox, isn't it? The very space that gives rise to civilizations, nurtures them and allows them to flourish, can also be the one to end their existence. So could the very space that cradles civilizations also be their ultimate destroyer? Imagine the unimaginable, cosmic catastrophes of epic proportions. Picture a star, many times larger than our sun, collapsing under its own weight, erupting in a supernova explosion. The energy released in a fraction of a second is more than our sun will produce in its entire lifetime. The shockwaves blast outwards, obliterating anything in their path, and the remnants can form a black hole, a region of space where gravity is so strong that not even light can escape. Now, let's talk about black holes. They are not just the stuff of science fiction. These cosmic phenomena are real and they're terrifyingly powerful. If a civilization was unfortunate enough to be too close to a black hole, the intense gravitational pull could tear apart their planet, their star, and effectively erase them from existence. But the universe has more up its sleeve. Consider gamma-ray bursts, the most energetic events known to occur in the cosmos. These are high-energy explosions that can release as much energy in a few seconds as a star does over its entire lifespan. We're talking about a flash of radiation that could wipe out any life within its reach. These events are not just theoretical. Astronomers have observed supernovas, detected black holes, and recorded gamma-ray bursts. They've seen the remnants of these events, neutron stars, pulsars, and the like. They are the celestial detectives, piecing together the stories of these cosmic catastrophes. Now you might be wondering, how often do these events occur? The answer is, not very often. The universe is a big place and these events are rare. But when they do occur, they have the potential to unleash destruction on a cosmic scale. So what does this mean for civilizations in space? Simply put, it's a cosmic lottery. The odds are low, but the stakes are incredibly high. These cosmic events, though rare, possess the power to erase civilizations from existence. Stars, the luminous celestial bodies, have a life too. Just as living beings on Earth, stars also have a life cycle, a birth, a middle age, and ultimately, an end. This stellar life cycle is a cosmic dance of elements, gravity, and energy. And it's this dance that can sometimes spell doom for nearby planets and civilizations. Let's start at the beginning. Stars are born from massive clouds of dust and gas called nebulae. As these clouds collapse under their own gravity, they form protostars, which continue to gather material and grow hotter until nuclear fusion kicks in, igniting the star's core and setting it aglow. This marks the star's arrival at the main sequence stage, its middle age, where it will spend the majority of its life burning hydrogen to produce helium and radiating energy into the cosmos. Yet, as we know, all good things must come to an end. Eventually, the star exhausts its hydrogen fuel and enters the red giant phase. During this stage, the star expands, its outer layers swelling to many times their original size. If a star like our sun were to become a red giant, it could engulf the inner planets, including Earth. spelling potential disaster for any civilizations living there. But the story doesn't end there. The red giant will eventually shed its outer layers, leaving behind a hot, dense core known as a white dwarf. Over billions of years, the white dwarf will cool and dim, ending its life as a black dwarf. However, if the original star was massive enough, it could undergo a more violent end, collapsing to form a neutron star or exploding in a supernova, releasing vast amounts of energy capable of wiping out entire planetary systems. So stars, in their birth, life and death, play a pivotal role in the cosmos. They are creators, nurturers, and destroyers. Their life cycles are intrinsically tied to the fates of planets and civilizations. Indeed, the death of stars can bring about an end to civilizations. Threats to civilizations are not just confined to their own galaxy. Let's take a moment to think about the bigger picture, the extragalactic threats. Picture the endless expanse of space filled with galaxies like our own Milky Way, each teeming with millions or even billions of stars. Now imagine, what if these galaxies collide? It's not a scene from a sci-fi movie, but a very real phenomenon. In about 4 billion years, our galaxy is set to collide with our neighbor Andromeda. But don't worry, it's not as disastrous as it sounds, at least not immediately. The vast distances between stars mean that direct collisions are unlikely. However, the gravitational chaos could fling our solar system into the galactic void, or even towards the center of the merged galaxies, where a supermassive black hole awaits. Next, let's consider quasars, the brightest objects in the universe. These celestial bodies emit a beam of intense light and radiation, powered by a supermassive black hole at their center. If a quasar's beam were to sweep across our galaxy, it could strip planets of their atmospheres and sterilize entire worlds. Then we have active galactic nuclei, or AGNs, the central regions of galaxies that are extraordinarily bright due to the accretion of matter by a central supermassive black hole. Some of these AGNs can produce jets of particles moving at nearly the speed of light. If one of those jets were to hit a planet, it would be devastating. The high-energy radiation could strip the atmosphere, leaving the planet barren and lifeless. But it's not all doom and gloom. These extragalactic threats also serve as cosmic reminders of how precious and fragile life is, and how we need to cherish and protect it. They underscore the importance of understanding our universe, not just for the sake of knowledge, but also for our survival. Even galaxies, it seems, are not safe from the destructive forces of the universe. In a universe filled with cosmic catastrophes, how do civilizations survive? This question might seem daunting, but the answer lies in understanding the grandeur of cosmic timescales and the potential for civilizations to evolve and adapt. When we consider the lifespan of the universe, our human timescale seems almost insignificant. The universe is about 13.8 billion years old, while modern humans have only been around for a mere 200,000 years. This vast difference in timescales presents civilizations with both challenges and opportunities. On one hand, it exposes them to numerous cosmic catastrophes over eons. On the other hand, it provides ample time for evolution and adaptation. Let's imagine a civilization that has survived for millions or even billions of years. Such a civilization would have had to navigate through a myriad of cosmic threats. Their survival strategy might involve evolving to withstand harsh cosmic conditions, or building technologies to protect themselves from cosmic disasters. But there's more to survival than just weathering storms. A long-lasting civilization would also need a sustainable source of energy. As stars age and die, civilizations might find their energy sources dwindling. This is where the concept of cosmic energy harvesting comes into play. Civilizations could learn to harness energy directly from stars, or even from more exotic cosmic phenomena. The idea might sound like science fiction, but it's grounded in the laws of physics. In fact, physicist Freeman Dyson once proposed a hypothetical structure, now known as a Dyson sphere, that could potentially capture and utilize the entire energy output of a star. While we're far from building such advanced structures, the concept serves as a reminder of the potential for civilizations to adapt and evolve. It suggests that, in the grand scheme of the cosmos, survival is not just about resisting threats, but also about harnessing opportunities. In the end, the survival of civilizations might depend on their ability to adapt and evolve in the face of cosmic threats.